Hello, Science 9. This is Mr. Chan. And what I wanted to do today was just give you a video that sort of reviewed the chemical naming, just in case some of you were having difficulties in class or you missed class and you wanted some reinforcement. Now, when we talk about chemical naming, a few that we have talked about was there was naming ionic compounds, and then we had naming polyatomics, and then also we had naming covalent bonding. All right, so I want to go through all three, and the video should take about 15, 20 minutes. Now, for naming ionic compounds, to make a chemical formula from the elements on the periodic table, one balances out the charges on the metal and the non-metal. So let me give you an example here. So let's say we had calcium and chlorine. Okay. Now, how I do it is I set as calcium and chlorine. And let's set this up. And I set it up like here. It says a charge, a multiply, and an LCM. Now, when we look at this, so step one would be finding the charge. Step two would be the LCM. Step three would be the multiplier. And step four is you write the formula. So how do we figure this out? So the first thing is you take a look at the calcium and the chlorine and you look for the charge. So going to your periodic table here, if we zoom in, we find that, okay, and chlorine, if we zoom out, chlorine has a charge in this particular case of -1. So that's the first step that we do, is we look at the charges for the different elements. So going back to our table here, going back to our little table, the charge here would be +2 for calcium and -1 for chlorine. Now, what you can do in your head is afterwards, you can ignore the plus and the minus. So what you want to do is you want to focus on what is the lowest common multiple of 2 and 1. And in this particular case, the lowest common multiple is 2 and 2. The key thing is for the lowest common multiple, they must be the same. Okay? Now, so in this particular case, what you want to do is figure out, okay, for chlorine, 1 times what gives you 2? And this would be a multiplier of 2. And for calcium, 2 times what gives you 2? And in this case, it would be 1. So what we would do is we would write out the formula Ca1. And where did I get the 1 from? That's right here in the multiplier. And we have Cl, and if I did it in a different color, 2. And where did I get the 2 from? The 2 comes from the multiplier. So when we write the numbers in the formula, what we're doing is we're writing the numbers in the multiplier. Okay, so that's one example that I gave. Another example that I gave in the work. So let's do another example on the side. And I think in the notes I did it on the bottom, but that's okay. So let's say, for example, I had, let's say barium, and nitrogen. So again, if we take a look at barium and nitrogen, we follow the same 4 steps. Okay, so what we have here is we have the charge, I'll just write the C, the multiplier, and the LCM. Okay, and I'm just going to go again 1, 2, 3, and then the last step is 4. Okay, so if we were to take a look at this, so again, we look at the charges. So looking at your periodic table, you look for barium. Okay, come on here. So, well, let's look for nitrogen first. Nitrogen, you notice it's a -3 right here. And if we look to the left-hand side, we find that barium, let me see where's barium. Barium's down here. It's a +2. So in this particular case, if we have barium, it is +2. Nitrogen is -3. Again, what you want to do is you just want to take away the 2 and the positive and the negative. You look for the lowest common multiple of 2 and 3. And in this case, it would be 6. Now, again, these need to be the same. So in this case, here, if we look at the multipliers, barium would be 3, nitrogen would be 2, because for barium, 2 times 3 gives you 6. For nitrogen, 3 times 2 gives you 6. So the formula would be barium, and what we have here is we multiplied it by 3. That is this multiplier here. And for nitrogen, we had 2, which is this multiplier here. Okay. So that's how you set it up. If you notice, it's the same 4 steps, 1, 2, 3, and 4. Now, for chemical name, for formula to chemical name, you just change the non-metal ending to IDE. So let's say for the 2 examples we just gave you. So for calcium, and we had chlorine, what happened is from the previous example, we found that it was CaCl2. And if we were to name it, it would be calcium chloride. Notice I changed the ending from INE to IDE. So that ending change means that the chlorine was actually joined up. Okay. Now, the other example I gave in my previous was, it was barium and nitrogen. So what happens is, in this particular case, we came up with the formula of Ba3 and 2. And the chemical name would be barium nitride. And again, notice I changed the ending to IDE. Now, as a rule, we always change, the general rule is you change the second syllable to IDE. So for example, chlorine is 2 syllables, chloride is 2 syllables as well. Nitrogen is 3 syllables, so nitride is 2 syllables, okay? Oxygen is 3 syllables, oxide is 2. Now, there are exceptions. For example, selenium is 4 syllables, so selenide would be 3. And the other one would be iodine. Iodine is 3 syllables, so it would be iodide would be 3 syllables as well. If we had changed it to 2 syllables, then it would be I died, and that would not be appropriate. Okay. Now, if we have the chemical name to chemical formula, it just says, remember to use the ion charge of the element. So for example, let's say we had sodium oxide. Now, for sodium oxide, okay, we still do the exact same thing. So in this case, the charge the multiplier, and the LCM. Now, so for sodium, again, you look at the periodic table, and if you look at your periodic table, you will notice that sodium here has a charge of +1. So in this particular case, we go back, sodium has a charge of +1. Now, for oxide, you might say, well, what is oxide? Well, oxide is just oxygen. So in this case, for oxygen, if we take a look, oxygen, I've already highlighted here, oxygen is a charge of -2. Now, that's one way to do it, but in your periodic tables, there's a little bit of a cheat that I provided for you. So if you look on the back side of your periodic table, you will notice this table here. It says negative ions. And what you can do is you can find, it says here, oxide is -2. Okay. Now, so that gives you the charge. And again, if we go back here, this is -2. Lowest common multiple is 2 and 2. Okay, so this would be a multiplier of 2. This would be a multiplier of 1. And so the name, again, this would be 1, 2, 3. And the last one is 4. So it would be Na2O1. So the 2 is here, whoopsie, right there. And the 1 will be right down here. Okay. Now, I just can't emphasize it enough that you need to write down the multiplier. Okay, it's not the charge, it's the multiplier. Now, if you are using elements with more than one charge, for example, copper or copper 2 plus, called multivalent elements, in this case, what you need to do is follow the same rules as before, but you use Roman numerals in the formula name. Okay? Now, so what do I mean by this? So what do I mean by multiple charges? So if you take a look on the periodic table, oopsie, where's my periodic table here? Come on. All right. You will notice in your periodic table, you will notice that elements like copper, notice it has 2 charges. Okay, so copper has 2 charges here. Nickel has 2 charges. Iron has 2 charges. And let's say even, oh, I don't know. Okay, so you notice a lot of these have 2 charges. Manganese here has 3 charges. So which one do we use? Now, you will also find this list on the back side of your periodic table. If you look on the left-hand side under positive ions, you will notice cobalt, they have 2 choices. Copper, there's 2 choices. Iron, there's 2 choices. Okay, so to distinguish which choice we are using, we have to use Roman numerals. So what do I mean by this one? So let's say, for example, I have the formula, I don't know, copper 2, and let's say oxide. Okay, so let's say it's copper 2 oxide. Again, we set this up. Okay, so we have the charge, the multiplier, the LCM. Now, in this case, oxide, like before, if you take a look, oxide was a charge of -2. Now, again, if you're not too comfortable of how I got that, there's 2 ways. Number one is you take a look at the periodic table and you see that oxide is just oxygen, which is a -2. Or you also have on the polyatomic list, remember, you look at down the middle column, you see oxide is -2. So what do you have here? So in this case, this would be -2. Now, for copper, remember I said copper, you had two choices. So copper, if you looked at the list here, copper was either a +1 or a +2. So which one did you choose? Which one does the formula want? In this case, the charge here would be +2. Why? Is because the 2 here tells you the charge that you're using. Okay? Now, again, you take this is the first step, you find the charge. Second step is the LCM, which is 2 and 2. Third step is you multiply both of these by 1. And so in this case, using these numbers, it would be copper 101. So this would be step number 4. Now, again, some of you might say, well, Mr. Chan, what happened to the 2's? Well, those are the charges, and we do not write the charges down. In this particular case, what we do is we just write the multipliers. So in this case, since I multiplied the copper by 1, that's why it's a 1 here. And here, if I multiply by 1, that's why I wrote the 1 here. Okay? Now, how about if we did the formulas to names? Okay, so let's say we did this one here. Okay, so let's say we had, oh no, let's say we had F, E, 3, and 2. Now, the first thing is it looks very similar to what we did back here. You might say, okay, Mr. Chan, we changed the endings to I, D, E, and so on. Okay. So the first thing is you go, all right, it's iron nitride. Now, you might say, okay, but now we have to take an extra step. You need to check, does iron have more than one charge? Is it multivalent? Is there a choice? So if you look at your the table on the back, you will notice that iron either has a +2 or a +3. So which one did we use? So in this case, what we do again is we have to set up the little table. So here, notice I'm setting up this table. So what you have is you have your charge, your multiplier, and your LCM. Now, looking back at the table, okay, you will notice it says iron had a charge of +2 or +3. But you also look at the table, you notice here, iron also has a +2 or +3. Okay, so that's two ways to check. So which one do we use? So let's set this up. So iron is either +2 or +3. Now, you might say, okay, no help there. But let's look under nitride. So in this case, for nitride, if we look here, it only has one charge. It has a -3. Okay, sounds good. So you go back here. So nitride is -3. Now, what can we do next? Well, we know the multipliers. Nitride was multiplied by 2. Where did we get the number from? It was right here. Okay. And iron was multiplied by 3. And so here, we're going to put down the 3. So we have -3 times 2 under nitride gives you 6. Remember, the LCM had to be the same. So this is 6. So 3, what times 3 gives you 6? And the answer is +2. So we can cross this off. So we know it's iron 2, Roman numeral 2, nitride. Okay, so this is, you have this extra step if you have an element with multiple charges. So if you take a look at the periodic table, and you have these like iron and so on with all these plus charges options, then you have to remember to use Roman numerals. Now, you might say, well, Mr. Chan, why didn't we have to do this with calcium? Why didn't we have to do this with barium? And the reason being is because looking at the periodic table, if we look at, oh, whoopsie. Let me undo this one. Okay. If we were to take a look, that's a little slow. If we take a look at sodium, notice sodium only had one charge. If we looked at calcium, calcium only had one charge. So if they are only one charge, then you do not need to worry about Roman numerals. Okay. What I'm going to do is I'm going to stop it here to give you folks a little bit of time to digest the material. And then what I will do is have a second video that sort of finishes off all the chemical naming. All right, folks, thank you very much. And if you have any questions, please feel free to come and see me during flex time. All right, take care. Have a good day. Bye-bye.